Hello everyone, my name is Zhehui Wang. I'm an undergraduate student in the University of Michigan. My major is Industrial and Operations Engineering. I participated in the short program this summer and work on a research project about nurse staffing. My mentor is Professor Mark Daskin, and I also worked with 2 graduate students. We first did data analysis. Then we built optimization model, simulation model, NewsWonder model, and nurse staffing tool. Finally, we improved the staffing decisions. You may ask, what is the NewsWonder model? Let me use a simple example to illustrate this idea. For example, I'm selling a newspaper, and I need to determine the number of newspapers that I have to purchase every day for sale. The purchase price of the newspaper is 50 cents. And the selling price is 75 cents. If there is some newspaper left at the end of the day, I need to recycle those newspapers at the price of 10 cents. If I know the possible number of newspapers that I can sell each day and the corresponding probability, then I can use the NewsWonder model to determine the optimal number of newspapers that I need to purchase each day to receive a maximum profit. What we discussed above is the traditional NewsWonder model. In the context of nurse staffing, we do some changes to the interpretation of the model. The selling price in the context of nurse staffing is 0. We change the purchase price of newspaper to the salaries of having a unit, pool, or temporary nurses per shift. The salvage value is the benefit of having 1 extra nurse on duty. Instead of maximizing profits, we minimize costs. We determine the nurse staffing level instead of the newspaper inventory level. First, let's look at the data analysis. First, we did correlation test among days. Here is the sample result for Unit 5E3. You can see the correlation matrix from the slide. We also find that all the p-values are close to 0. In conclusion, there are positive correlations between day-of-week data. No negative correlation is found. We also find that Monday census is closely correlated to Sunday census. Then we did the correlation test among months. Here is the sample result for Unit 5W2. You can see that correlation exists among consecutive months. No significant correlation from June to July and from October to November. This is perhaps due to the new resident coming in and the holiday season. Then we did the correlation test among years. We find that census level increased for most units from 2007 to 2008, and from 2010 to 2011. We find that unit NICU had decreased census level from year 2009 to 2010. Last, we did the correlation test among units. We find that positive correlation among most units. However, the negative correlation exists between PICU and 6M units. After analyzing the correlation in the data, we did the distribution test. We are considering Poisson and truncated Poisson distribution. X-axis is the census level. We set Y-axis as the frequency corresponding to the census level. We use chi-square goodness of fit test and Monte Carlo test to test for the distribution. We find that Poisson and truncated Poisson don't fit the data. This is perhaps due to the operational changes that affected patient census levels. The following is the 3 nursing levels model diagram. We use this diagram to illustrate the linear model we built. You can see that each unit has its own staff nurses, and the 3 units share the same float nurse pod. The nurse manager will have the temporary nurses if the staff nurse and float nurse cannot satisfy the patient demands. Then let Casey introduce the integer linear model.
I am Casey Moss. I'm a second-year PhD student in the Department of Industrial and Operations Engineering at the University of Michigan, and I've been working this summer with Joey on the nurse staffing project.
We've developed an integer linear model to determine the optimal permanent staffing levels of the unit and CSR nurses. The model requires the following inputs. First, we need to specify the set of nursing units for which we want to determine the optimal nurse staffing plan. We also need to specify the cost of hiring a unit nurse, a pool nurse, and a temporary nurse, as well as the benefit or the salvage value derived from having an additional nurse on duty. Finally, we must also specify the set of scenarios we wish to consider, the number of nurses needed in each scenario, and the probability of each scenario occurring. Our goal is to find the optimal permanent staffing levels, which includes determining the number of unit nurses to hire and the size of the CSR flow pool. Since we are making this decision over a long-term planning horizon, we do not know the actual patient census levels for the future days. Because of this, we must consider the staffing costs associated with each daily scenario if we choose a specific long-term permanent staffing level. The model then allocates the CSR pool nurses to units, determines whether temporary nurses are needed, and specifies the number of salvage nurses on duty.
Here is the mathematical formulation of the linear model. The objective function is to minimize the cost of unit, pool, and temporary nurses less the salvage value of actual nurses. The first constraint is that patient demand must be satisfied. The second is that all pool nurses must be assigned to a unit. There is also non-negativity, binary, and integrity. We build a simulator. Our goal is to develop a tool for nurse managers to use when determining the number of unit nurses and pool nurses to schedule. The simulator will display the cost difference between the optimal suggested staffing levels and the user's desired staffing levels. Our simulator is based on the historical patient census data. It could also be based on the probability distribution of the census data. The outputs of the simulator are the number of unit nurses to hire and the size of CSR flow pool. Here is the simulator layout. The users can input their desired levels. They also need to input the patient-to-nurse ratios, the cost of each type of nurses, and the salvage value. After input all the necessary data, they can click on the Filter Data button, and then a form will pop out. This form will enable the users to select the range of data they want to analyze. And after they click on the Filter button on the form, the simulator will run and calculate the optimal staffing levels and the optimal cost, and also the total cost corresponding to the desired input levels. Then we develop a staffing level tool. Because nurses are unsure of which table to use to find out staffing level, and the overstaffing happens when the nurse managers round up staffing levels for registered nurses and the techs at each shift. We hope that this staffing tool could replace the tables to avoid confusion for the nurses, and it could be a more flexible tool due to the what-if capability. Here is the layout of the staffing tool.
So thank you. I just wanted to say a few things about this project. I think it was a great project. First, it's a very real problem. Nurse staffing is a problem that's important both at the University of Michigan Health System and throughout the country. It's just about every hospital in the country. We were fortunate in that we were able to get a lot of good data from the hospital. Jay Wei and the other students worked on that data. They were able to find important correlations across days and across months. We then were able to use the data in an optimization model, both a linear optimization model and a nonlinear optimization model, to determine optimal staffing for the hospital for various units. And then we were able to implement those staffing levels in a simulation model so that the hospital staff could evaluate the proposed staffing against some of the staffing that they thought might be better. And I think the students did a great job this summer, and I'm very proud of them. It was a great project.